Okay, so we are live on Facebook also, and we are recording as well. So when it started. Okay, so Sajja, do you want to add anything? Okay, so let me share my screen first, and then we'll move from there. Okay, so last week we have completed our step 03, in which we have completed the solidity tutorial from the article we have discussed. So in last class we were covering all the inheritance and the object oriented part of the solidity language. Today we are going to cover step 04, and for step 04 we are following a book which is this one, Mastering Blockchain Programming with Solidity. It's still an older book. It's covering the Solidity 4.25 and Solidity 5.0. But the problem with Solidity is being rapidly changing. There are rapid changes in Solidity. Every few weeks or a month, there are new changes and new features and new functionalities. So that's why to find up-to-date content related to this Solidity, it's quite difficult. So we'll follow this book for a few of the concepts which were not available in the article, and so we'll cover this from chapter 2, and then we'll move forward and see whatever the topics available to us and what we need to cover from them. Okay, so for starting from chapter 1 is an introduction as a whole, Ethereum and the blockchain. So we are not going to cover it. Chapter 2 has few many things which we have already covered. So I'll skip them and directly move to the point where we need to discuss and what we need to cover. So solidity layout and the contract structure, functions, modifiers, all these things have already been covered. We have already covered structures, data types, and all those things. So what we need to cover today is even for the address type, we have already seen transfer and send, how these works. From where we need to start is the call, delegate call, and static call functions for the address type. So first we'll talk about these, and then we'll move forward and see what topics we need to cover. Okay, so in our previous class, or the maybe 2 class back, we were discussing the transfer and send functions, and we also have there are discussion come up where we discuss that there is also call and delegate call functions available in address type. What are their use, and what when we will be using them. First of all, call, delegate call, and static call functions are available on address data type. And what we do with them is we basically can call a function of a contract, a function available on that particular address. And these are the low level calls. Basically, these are the low level calls. These because you will be not be calling a function as a dot operator. You will be encrypting a function name, and then you'll be sending to these functions. So basically, they are low level call, and they should be last resort of your call. Generally, what you do is you create a contract, you have a reference of a contract, import that contract in your code, and then call the dot using the dot operator. But sometimes you do not have a code of your application, code of a contract which you wanted to call. So let's say you were developing an application and you wanted to call a code of a particular contract which is separate. It does not belong to you, but you can call them because they have the public functions. To call them, what you need to have, you must have ABI, abstract binary interface, into your code, or you can create an interface so that you can call within the Solidity contract. If that's it not available, then what you can do is you can directly call by just sending that this is the type of function I am expecting, and these are the value you should pass to them and then call them. And these are the really low level functionalities to call. So how you can do this is basically on address, you will send the call and you will pass the signature of your function. So I will show you the code. Let's say if you can see this, you have an address, and on that address you are sending the .call function and passing the method name. This is not the way we will pass because this will not work. I'll show you the right way to call. So you will call the call and delegate call. So they will be exactly like we'll be calling another contract. So now let's move to the code. So we have a contract, second contract, it has a function, let's say do something. And what it does is update some value.
Prashant, could you please
Yes.
mute everyone again?
Sure. Just a moment. Done. Okay, so I have written this function, which is very simple. To see, we need to see a lot of actions. So what I'll do is Hardhead provide us the logging functionality. So I'll use that one as well. Console.log. So I'll add other properties later. So this is the contract, and we have this contract has a function named do something. Now what we need to do is we need to call this function inside this contract. So let's say function our function test, it is a public function. And if normally what we do is we call import dot slash so, and somehow why it's all green. Okay, so generally what we do is we call, let's say, second contract abc equals to new second contract abc dot do something. That's how we generally call if we have the code available. But if we do not have the code, so what we can do is we need to have the address of a contract. So let's say in the constructor, I will accept the contract address equals to underscore contract address. And here what we need to do is we need to call them like this: contract.call, or a delegate call, or a third one is a static call. So what I'll do is I'll say contract address dot call. Now what I need to do is I need to pass this name of a function. To pass this name of function, we have few functions available in ABI. ABI dot encode with signature. So what we'll do is we'll encode our function as a signature, and then we'll pass few arguments. So this second contract has function do something and it does not take anything. So I'll pick this and I'll pass it over here like this as a string. And at this moment, we are not sending any parameter. I'll show you how we can send the parameter as well. Let's first look into this and then we'll see. And what it does is it returns two parameters, Boolean. Because if this function fails, it does not crash the application. It will not cancel the transaction. Your transaction will get succeed, and it will not. You will not able to find out what has happened. It will not show you this. So only the success variable, which is if it's true, that means this call of this function was successful. If it fails, transaction fails with any reason, whatever the reason there will be in the contract of a failure, you will receive false only. So your transaction will not fail, your execution will work exactly fine. So you have to see if your code is working fine by checking if it's successful or not. At this moment, I'm just for us to understand what the way it will return the value, I'm logging it in the console. Otherwise, we will not be doing things like this. Okay, so okay, so what we have done is we have created a normal contract which has a public function and it's just doing some calculation, and we have to call this function from here. Let me npx. Okay, that's done. It's just a warning as we have not been using this variable, so it's compiled, and now what I need to do is we need to use them. So I need to initialize both of these contract, deploy both of these contract. Second contract, then call function. Okay, so now the second contract is will be deployed from this code, and the address of second contract will pass from here. So in this case, our call function demo contract asks the address of a contract in constructor, so that will be passed in the deploy function. So we'll say second contract dot address. So once this deployed, what we can do is we can call this function called caller test function, and what it will do is it will, on this address, it will try to call do something function. And again, this is the low level call, and you would be only doing if you do not have any access to that particular code, or generally if you guys have heard about the flash loans and everything, that's where it will be the most useful. Okay, so once this is done, we'll call the transaction ether caller function demo dot okay. So if it's everything goes well, we do not have to return anything because we have these logs available, so it will show us in the logs. So at this moment we are good to go, and we can deploy it and run it so that we see what happened. Okay, so we have not seen any error at this moment, but on the way where we started the node, we can see the logs. Second contract demo, which is this one. So I'll show you some values over there as well. And the call function caller success equals to true. So when we issued the caller test function, the call went to this function, and it calls the do something function. Inside this do something function, the call initiated for this function. So we can see easily the logs over here, which is proof that this function gets called. And once the call is successful, we have seen the result, and it says success true. So that's one thing. So you can call this like we have done here, call, or you can say call delegate. At this moment, you might not see any difference. Delegate call. Okay, so this is exactly same. There is no difference at this moment, or at least. So let's first add the parameter, then I'll show you the difference between the call and call delegate. So let's say this do something function has some, it's asking for, let's say, UN256 underscore value, which we will pass into the, actually we are passing value from here. We will pass value from here, and it will be available over here, and it will update this. Okay, so now to call this, because we are asking for the UN256, so what we have to do is we have to make it signature like this, so that we are calling a function which has which is asking for U into 56 and comma, whatever the value we wanted to pass. So in value, let's say I wanted to pass 12. And inside the function, it will update the value of this contract. In the deploy, let's just check console.log before, which will call the second contract dot. Well, it is in the second contract. Let's make it public so we can access it. Okay, so we have not seen any change 5.5. Yes, now we have to okay, you can see 5 and 12. So what we did is we actually send the function, we call this function, we pass the value 12. It went to the second contract and updated the state variable of the second contract. Now, so that's we can pass the parameters into the function and all those things. Important thing is the difference between these two. You just saw that when I was the call was the delegate call, it was not the value was not updated here. Both were 5. The difference between call and delegate call is call the construct call calls the function of another contract, like we are calling a separate function. We are calling a separate function of a separate contract. All those storage and the usage of functionality will be considered as the second contract is being called. Whereas when we use the delegate call, so what happened is when we issue a request with delegate call, so that means we are actually accessing this function just to show you, just to and that will be the part of this contract, everything. So it will be like you're calling a function within the same contract. So delegate call will make that function part of this current contract. So it will be like that function will become part of this contract and it will execute in the context of this contract. And whatever the changes happen in this function will actually be updating the state of this contract, not the second contract. So to understand this, just look at it again, that we have this contract, second contract, it has a variable val 5, and whenever we call the do something, it updates the val variable. When we use the call, what it will do is it will call do something, and when it tries to update the state, it will actually update the state of second contract, not the contract which issued the call. But in delegate call, it will try to update the state of this contract. How we can see this? What we have to do is first we have to see that this is the variable we have. Now what we can do, we will keep this variable here as well. exactly similar variables. So both contract has the same variable name u into 56 well 5. So the call function have this variable, and second contract has this same variable. Now what we can do is when we use the call, let's make it two functions so we can see the difference. Okay, so let me add few more things. Do something.
Excuse me, sir.
Yes.
Excuse me.
Yes, yes.
Sir, kindly increase the font little bit. This is not clearly visible.
Is it okay? Is it okay now?
Yes, it's okay. Thank you.
Sir, if you allow, can I ask some things now? Things are getting piled
Yes,
up.
yes, please.
So, like, we will use these methods only when we don't have ABI of the other contract, yeah?
Yes.
And second thing I would like to ask is that what if we declare this variable as private? Will it still change the state of the other contract?
Yeah, because basically it's part of this contract. I'll show you just a moment.
And what if the function itself is private, like it should not be accessible with the delegate call or
Then
whatever?
then it will not work. It will give you the error.
And even if variable at the state level is private, it will still change the state of the other contract.
Yes. Because it is within no, it is within
But
the
sir,
function. It is within the function. I'll show you. Give me a moment. So
okay, sir.
let me
Okay.
build.
Okay.
Okay, so at this moment I have added few because what we need to understand is when we call a function from the calling is being considered from the separate contract. Let's say when I do the when I issue the call request, the message dot sender will be the call demo function. But if I'll do the call delegate, then the message dot sender will be the initial person who issued the call. So once I'll display all those things, then it will be easy to understand. So we have add this message dot sender, so we can see that who is calling this function, who is initial caller of the transaction. So transaction dot origin is the very first person as external account which issued the initial call, and the address is the current contract address. So it will be the second contract when we will be considering the second contract and the value. Now in here we one of the call is call and the second one is okay. Now we have this well property in both of the contract. Okay, so we have this well property in the second contract, this well property in call demo function contract as well. And in the caller test function, we are using the call. And in the second one, the delegate one, we are using the delegate call. So I'm just calling just the caller function, the simple call function. Okay, so very first thing you need to observe is the address of second contract is A51C ends with 91C0, and the address of a call demo function is 0DC and ends with CD82. Just to remember these. And if you see, the call demo function has a value 5 before, second contract has a value 5 before. After the call demo function is still the 5, but the second contract has the value 12 because the call updates the state of second contract, not the call function contract. Now let's come to the console. Inside the second contract, here we trying to check who is the sender of a call. The sender of a call is BCD82. So BCD82. Now, what we are trying to do is basically from the deployment script, a particular address, the very first address will issue the call. This call will go to this function, and the call demo will call this caller function. And then inside this caller function, we are calling another function called do something. So the caller of this do something is this call demo function. That's the difference in the call, that whenever you go step by step inside the contract, you call the contract function of another contract, then inside the function you call the function of another contract. The caller of that function is the previous one who called it. So in this case, the call demo function contract calls this do something. That's why message.sender here is the call demo function contract, this one. And the transaction.origin, this is the original account. If you let me show the initial addresses, this is the external account which started the execution of a calls. Third thing, address of a current contract 91C0, which is the second contract 91C0. So that's one thing. And actually, and it's updated the call. Now let me go and change the
Excuse me, I have a question. If our contract is calling another contract, which is calling another contract, whose
Yes.
contract is going to be charged for the gas?
initially the external loan account will be charged for the gas, none other than, in all these scenarios.
Thank you.
Okay, so now what
Thank
you need to understand is, again, what we did is, now we are calling the delegate function, which is this one, delegate call. Calling the same we are calling the same function, but with the delegate call. So you see the address of a contract is 7016. Address of a call demo contract is 0071. If you see the changes, call demo function has a value 5 before, second contract has a value 5 before. Now that's the difference. Call demo function's value has been updated. You see, the function which we called is from the second contract here, but it's updating the value. It's not updating the value of this contract. It is actually updating the value of this contract. That's the main difference. Delegate call calls the function as it is the part of the current contract. So all the state storage will be used as the current contract. That's one thing. Now, second thing, you see who is the message dot sender? 266. Who is the initial caller? 266. So the advantage is from this script we call this function. So the caller was address 266. Call goes over here. It starts to call this using the delegate call. Call reach to the second contract, but here this call will not considered as it is being called by the call demo function. It will considered as it is being called by the initial caller. So the context of the function will be different. So now the message dot sender is 266. Transaction dot origin is will be the same because that's the address which initiate the transaction, and current address we are saying address dot this. That means address of a current contract. So what it says 071B. 071B belongs to call demo function. You see, it does not belong to second contract. So this function, you see, it's actually working as it is part of this contract. That's the main idea of it. And it gives you the advantage in many time when you have a bigger domain. There are many contracts, and inside the one contract you call the function of another contract, and that function calls another contract. But what happened is all the time message dot sender gets changed. So either you use the transaction dot origin, but transaction dot origin is the one which you need to set. But whenever the contract gets started, you, let's say inside here, if I wanted to create a contract, let's say there is a contract ABC A equals to new ABC. So we cannot say that it should be the called by the transaction dot origin. It will always be this contract, the second contract. So the owner of this ABC will always be the second contract. The message dot sender for this call will always be the second contract. If we wanted to make the owner of this ABC the caller who initiate the call, then we have to use the using the delegate call. That's the main difference. I know there are many questions, so we can start discussing those questions to address this, and then I'll explain it once again, and then we'll move forward. So is there any question or any confusion?
I need to ask one thing. So don't you think this is a security concern? Like we can change.
It's a big security concern. It's a big security concern.
Yeah, we can change a state of another contract regardless of its access modifier, whether it's private, internal, or public. Then how we can avoid this? If let's suppose if we change the function here, do something. If we change its access modifier to internal or private, will it still be applicable? Like delegate calling will still work?
Basically, what you need to understand is, if you are allowing a function that can be called publicly, so either I call it like this or either I call it with any way, it will be allowed. So what you can do is you can apply some filters here. Require, and at the creation of this contract, that will be the additional, but just to
sir, if we make val variable private, even though we can change it to delegate call or no?
Just a minute. Let me answer this and then I'll show this the private and public. Okay, so now what we can do is owner equals to message dot sender. In this case, we are saying that only the one who created this contract can call this function, can call this contract. So we can apply these kind of filters on our contract, but that will be on the sensitive functions which we want only only owner can call. But if we have a function which is public and anyone can call it, so we need to allow them to be called by the public anyhow,
In this
and then
case,
we
sir,
can apply other filters.
yeah, sir, like if in this case, in our particular case, which we are discussing now, in function do something, if we change the accessibility modifier of this function from public to internal, will delegate calling still work?
No, because it's an internal. In case of internal, it will give you an error.
So delegate calling will not be applicable.
Will not be applicable. You see, success false. So it's actually does nothing. Again, because as I previously said, in these scenarios, it will not fail the transaction. It will just give you, it will just return you the false. So you have to consider the value. If it's false, that means there is some problem on the call of that function, because that's call coming is being done on another contract. So it does not give you the any error about it. You just have to check if it's a true or false, then you have to consider based on this. So at this moment it's written as false. Let me show you. In previous calls it was true, so that means call was successful. Now it's failed, it's showing us the false.
So my last question, I'm just
Yes.
sharing my understanding. So why it is why delegate calling is able to change the private variables, private storage level variables, because the message are sender is the current contract. Yeah, like second contract will be message are sender.
Let me just change it to private variable. Our code should give us an error, because in script we are accessing those variables. Okay, so the call is done successfully and it's updated the value as well. You see, so it's updating, as I previously mentioned, that it's updating the private variable, because actually this function will become part of this contract. So if it's part of this contract, the contract within the contract function can update its state, whether it is private, public, or internal. So it's trying to trying to update the value, and it is being updated. So that's the simple thing.
Thank you, sir. Thank you so much.
Okay. Now one last thing. At this moment, as you see, this is the very first variable, and the second variable is address. Here we have, again, this is the very first variable. If this is the sequence of variables that needs to be same. So if I let's first make it public again, so we can call them. And yes, fail based on the sequence of parameter. The sequence of storage should be the it should fail 5. We are actually updating the value, and value is not being updated to 12. So why it's saying the true value is not being updated. Value is not being updated, but it should also return the false. Problem is, what I'm trying to explain is, when you trying to call the with the delegate, when you try to use the delegate call, it's trying to access the state. So the state of this contract and the state of this contract we are trying to call should be the in same order. So if we have 3 or 4 variables, one is val, one is, let's say, string. So at this moment we have 3 variables, but the problem with this is it has only one variable, and it is the very first one. Here the first one is the address of a contract, and the second one is a string. This one is the last. It should return you the error. So in this case the call should fail. At this moment it is not failing, but it should be. Actually values are not being updated, but it should also return the false.
So sir, we have to follow the pattern. Yeah, like if a string is at
Yes.
the first place, we have to put first string in delegate calling.
Yeah, at this moment, as you can see, it's even though it's returning the true, but the value is not being updated. So all of those properties you can see, these are the only 5. So to make it work, what I have to do is I have to make well as the first one, and because there is no comparison about the others, so it will not matter. You see, now it's being updated. It was 12 previously. There was no change in the value. Now the value is being updated. So now basically what we need to understand, the call and delegate call are the lower level function, and the static call, which I'll just show in a moment. Call, delegate call, and the static call, all 3 functions are available on address data type. They are available for lower level call when you do not have the actual contract code. You saw some address or some project on the blockchain, and it has a public function. You wanted to call from your from your project. At least they, if you are using any public blockchain which they provide the contracts as a public repository, then you do not have to worry about, you just import those contracts. Even it should be your last resort, that you can call these functions like in this way. So what it will do is it will call those functions, and you do not have to that contract to be part of your code. You just issue these calls, and it should be the correct address. So it will just go on the blockchain, and it will call that function of a particular contract, and will return either is successful or not. So that's one thing. Even within your contract, within your project, as I showed here, that your one contract is calling second contract, and that second contract or calling another contract. At that point, we are trying to initialize another contract. Let's say you are creating a marketplace for NFTs. So you wanted to allow people to come and create NFT. So they will not be actually creating the code. They will hit a button and you have to deploy an NFT contract. To deploy an NFT contract, you have to call function of your code, and in that code you will say that will be the ABC NFT A equals to new ABC NFT. So whenever someone calls this do something, you'll issue this call and it will deploy your NFT contract. So you can create a marketplace where people come in and just create NFT without writing any code. But in this case, owner of this NFT will be this second contract, because this second contract is the message.sender for this NFT creation. So the constructor of this ABC NFT will consider second contract as an owner. We need to break this. For this, what we can do is we can issue a delegate call from here. We will issue a delegate call, and then delegate call means someone calls this function, which is in external on account. So we have allowed a person to press the button, and we take the address from that person, which calls this function, and this call will go over there. It will go over there, and the message.sender will be the person who initiate the transaction. It will be the message.sender inside the abc.nft, and the owner of this abc NFT will be the person who actually started the transaction. So that's when you can use this delegate call as well. Fair enough. Any more questions? So we can see.
Sir, we are using this dot call method in value transfers as well. So which type of call is that?
Value
when
transfer?
If we are sending an ethers to from a contract to EOA or somewhere, we use that payable dot call. Then we put value like balance or whatever is defined in the contract. So which type of call is that?
Basically,
for withdrawal we are mostly using it. Yeah.
Yes. Basically, for withdrawal, we have address.send, address.transfer, and address.call as well. Now the recommended function is you do the address.call. You do not issue the address.send or transfer. New recommended is the industry recommend is that whenever you wanted to withdraw or you wanted to transfer funds to your address, call contract address.call. When you do this address.call, what you do actually do is, let me just let's say this is how you will call withdraw, and inside that withdraw, what you do is you will say call, and here you will say okay. So that's something we need to discuss moving forward, but based on your question, we can so in this call we'll send empty. So while sending the empty, what we are trying to say is it will go to the address and it will just call the fallback function. So because if it is in normal externally owned account, then that will be the function transfer, that will be the ether transfer call. If it's in a contract, then it will call the fallback function, which we have discussed, the receive and fallback in the previous class. And what it will be transferred for that, I'll explain in a moment, but that's how you do. So whatever you wanted to add the properties into the function, if you wanted to transfer something, the payment or the gas, you call like this. This is the new way. Just let me complete just one thing.
Sure.
these discussion is actually over there, so we can discuss over at this moment right now. So whenever you call a function, what you wanted to do is you wanted to limit the gas, that caller should only consume limited amount of gas. Previously, as you will see in this book, it is call.gas. It was like this. But now, as Solidity gets updated very often, what you can do is you can call gas colon and assign the gas units like this. That's how you pass the gas, or that's how you pass if that function, the function you are trying to call is a payable function. That means you wanted to transfer ethers to that function as well. So you will say value colon in the way, so you'll assign this value. That's how you call the function when you wanted to pass the gas and the value. That's how you call it.
So it
And
is
can
just
we add
because
data
that
here as well?
I guess 2% was asking. Yes.
Can we add data here as well, like gas and then value, and if we want to send some data as well?
Data is already available. You can inside the call, whatever the data you want to pass, that will be here. The
Okay,
data
sir.
will be passed here.
And what if by any means, if our receiver contract which we to whom we are sending ethers is not having any fallback, then which function it will call? This ethers will be lost, or
If it's in a contract,
yeah,
if it's in a contract, then the transaction will fail because it does not have a fallback and the receive function. If it's an address, the fund will be transferred.
yeah, anyway transfer. Thank you, sir.
Sir, I just wanted to know that the practice has changed just because that transfer function or send using the limited, like a fixed amount of gas, like a 21,000. If I'm
Yes,
not wrong.
yes.
That's why
Yes.
we are using the call. In the transfer case, it can there's a chances it can fail the transaction.
Yes, that's the main reason. That's the main reason, and that's why it is recommended to use the call, so we can assign the gas as well.
Thank you.
And here this calling is not low level calling, I believe. Yeah.
No, it's low level call. The call delegate call, and this call as well. All these are the low level calls.
Or inside payable, it's still low level.
Yes.
Thank you, sir.
Now static. Static call. I guess that's the right spell. Okay. Now the difference between what the static call gives us, that in whenever you are trying to call a function of a contract using the static call, that function should not change state of a contract. Either the contract it is in, or the one which is calling. So it cannot change the state. So that function should not change anything. So if we go to here, the contract is same. It's trying to update the value, and we have this another function, caller function static, and it calls the static call. What we can do is we can go to the deploy and change this, just this one, and try to run it. You see, it's returning false. Why? Because the contract is trying to change the state of a function. So if I'll comment that out and run it again, success true. That means it's whatever the functionality within this contract is working fine, but it will not be able to change. So in this function, you will, if this function has some properties, which is some statement that is updating the state of a contract, then this function call will fail always. So using the static call, it will be like we are calling a pure function or a view function, which does not change the state of a contract. So call will be the call as an calling an external function. Delegate call will be the call, will be calling the function as it is part of the current contract, and a static call will be calling is an independent contract, because there is no change of state. So as you can see in this, it's calling as a separate contract, not part of a contract. So message.sender is different. So only delegate call consider that function as a part of that contract. And in the static call, you cannot change the state. That's three things. Any questions?
Can static call change any variable which is declared inside the function?
Yeah, inside it's whenever we try to use this view or pure function, inside the function is always available to change, because it's within the context of the function. It does not affect the state of a contract.
Yes.
The condition is based on the state of a contract, the state level variables.
Thank you, sir.
Sir, I want to ask one question.
Yes.
Can we send the custom gas fee in our function, like as we send the static fee in our function? Can we change it later?
Can we change it later? What does it mean by can we change it later? At this moment, what I'm trying to do is I'm trying to, let's say, trying to call this static call, and I can say gas colon that's max I can do. That's the custom value. And whatever you wanted to pass it. So whenever you call this function, you can pass this gas value over here. But that gas value should be, actually, you need to understand that when we try to call this function from the external world, the caller estimate the gas price, gas value, and provide this gas value from the contract. So from the external account, the one who is calling this contract, who is calling this contract? We have seen we have seen this. So this is the owner. So all these statement will be executed for this address. This is the external owned account address. At this moment, we are running the local node. So this local node, which started over here, it has given us these few addresses, these 20 addresses, and the very first one is this one, 22266. And when you use the square bracket and access, you can name it anything, but I'm naming it owner. So all these transactions is from the this address. Now, so all the gas coming in from this address, whatever they estimated it based on, the hard hat estimated it, and then it went to this call. Now inside this function, when I say pass some gas value, that gas value should be within the range of gas coming into the this for transaction. Otherwise, if you try to pass any value which is not within the range of gas already come in, then it will fail. That's what you can do. Okay. Now, as I have already shown you these properties, the gas and the transfer of value. So we can transfer the value like here. when inside the withdraw, what we can say is value you will normally see these type of calls within many of the NFT contracts and the ERC20 contracts. So whenever some people mint the contract tokens, the ethers come into the contract. From that contract, we can the owner of a contract can withdraw the ethers from the contract. For that, they have to write the withdraw function. That withdraw function should be public and can only be called by the owner. And then you say the contract address or whatever the address you wanted to use, the address of an owner, use the call, and then don't consider this contract as, because this is the something we were using for our example. So it will be the some externally owned account address, and then we'll pass whatever the balance is, just transfer to that particular address. So that's how you can transfer it. So to call the gas and to transfer the ether, you can call functions like this. So fix all these arrays, and it's been what we need to consider is, yes, now we need to see what Solidity has given us is we can pass function as a parameter as well, and we can return function from the function as well. So it's kind of an dynamic, like what we can do with JavaScript as well. We can start call the we can create higher order functions like we do in JavaScript and TypeScript. We can create higher order function which can accept another function, which can return another function. That can also be done with Solidity as well. So what we can do is we can call this dot method dot selector. What it will do is it will return the name, 4 bytes value of name of your function signature. And you can see here we are passing function as a parameter. So it is a function name iterate, and it is accepting a function. And maybe it has we have a function which is, yes, we can see internal pure returns. We are returning a function from a function. So we can pass a function to a function parameter, we can return a function from the function, and we can do all those things. What the advantage we can get is, for that, let me show you first how channeling is doing it. Because everything channeling is doing is built on 2 main things: the callback function and the events. So channeling has mainly, there are many things, but mainly how channeling has been able to access the external calls and all those things which channeling does. So for that, let me show you. So first thing, we should understand that we can pass a function to another function, but why we need to do this? So chain link. So at this moment, if you don't know what channeling is, how it works, just forget about it. What channeling, just to understand, within the blockchain, we cannot do any external call to any HTTP server or any we cannot generate any random number, or we cannot do anything which is not available within the decentralized network of a blockchain. So channeling gives us the bridge, so we can talk to the real world using the channeling. So forget about it as well. You can see in channeling, just consider the callback function. What we need to do is, if I call a function, when it's done its work, it can call my function later on. So we wanted to implement a callback functionality within the blockchain. For that, if you see here, chainlink.request using something, it's sending the address and it's sending the signature of a or selector or a name of a function, this dot fulfill dot selector. Once we call this function, this request initiated and it goes to the chainlink server, it do whatever they wanted to do. Once they are done, they wanted to update us that we are done and this is your result. For that, we have created a function. So that's the recommended way. I'll code it and show you guys as well. So you can see
So like
the
sir,
fulfill function.
with Chainlink, we can access oracles directly.
Yes. So you see, this is the fulfill function. And we have passed this fulfill function's name over here, this dot fulfill dot selector. So once we call this function, this request volume data, it will go to the chainlink server. Chainlink server do whatever they wanted to do, and then they wanted to update us. So they need to have some callback function so that they can call our function. For that, we have sent this function, and then chainlink will call based on this address. They call this function, and then this function will get called. So that's the real world example how and why we need to call an function, why we need to pass a function as a parameter, and why we need to call return function from the parameter from the function. Now for us, okay, so one more thing we need to understand, that when you wanted to pass function as a parameter, it can have two type of access modifier, internal or external. It cannot have a public access modifier. So what the problem we'll face based on this, I'll show you here, and then you will understand what the problem is. Okay, so for the request demo, that's the request class, and that's the function which we'll call. So let's say what I wanted to do is okay, so I'm trying to, so that's the function we have. It's a caller, so it will call this function, and then we'll pass a function into it. You in 256 value. So that's the function which we want to be called. And from here, what we can do is we'll be sending this function to a function inside the request demo. So actually, from the client side, we'll call this function only. This function will pass this receive function to the request demo function. So here, what we can do is we can say function receive request. It's accepting the address. And it will receive a function signature, which will be in bytes 4. I'll show you both. We can use the function as a defined type and as a byte 4 as a signature. I'll show you both. Bytes 4. It's bytes 4 or byte 4. I just got confirmed. Bytes 4. Okay, so now what we have is we have this function which will receive address of a contract and the signature, and it will do some processing, whatever the processing it will done. Once the processing is done, it needs to call the function which is being sent by the. So that's how we can create a callback scenario where you send a request, and like we do in Ajax calls. So we call this server and we pass the function. Once the server is done, it calls our function back. So request demo. Inside this request demo, we will okay, so we'll say we have to import rc dot receive request, and this receive request will pass the address of current contract. So we are saying that call function on this contract, and we need to pass this function. So now how we can pass this function? We have two options. We can pass complete function as well, but there is another option, API dot encode with selector. Okay, we already have receive data, this dot receive data dot selector. So we call this function. Whenever we call this test function, it will create this contract, send the request to this contract. Request will go to request demo class. It will do some functionality, and then from here it will call back this function. This one, receive data. Now, how we can do this inside this contract? We have already seen this call and delegate call. either use the call or the delegate call. You can do this API dot encode with selector, pass this over here, and we also wanted to pass the parameter. So what we are trying to do is we are trying to call a function which is passed from here, and what that function is, this is this one, and it accepts the u in 256. So we need to pass the value as well. So from here, let's say assumingly we are sending the 45. Now whenever someone calls this function, it will start this request, it will send receive request function to this, it will accept this signature or a selector of a function name, and request will go to this request demo function over here. It will do whatever the functionality they wanted to do, maybe take time to do all the transactions and everything. Once it is done, it will calls back this function. So within the context, what we are currently doing, it will not be asynchronous, so everything will be in sequence. But as I showed you the example of chain link, what we are trying to do is we wanted to send the HTTP request. So we call the chain link contract. Behind the scene, chain link contract do something. I'm not going into the detail what chain link does, but chain link calls the HTTP request. So it's sending the some request to some external server. So your transaction here will be end. And once the HTTP call is completed, then they will call your function. So then you will see the real asynchronous and the callback scenario. In this moment, at this moment, we'll just sending the request. It will go to that request. Once it is done, it will call this function. So it will all will be in sequence at this moment. Okay. So it is done. And
So in low level calling, we didn't told it the type of the parameter, like it's UN 256 or whatever.
basically we are sending when we are sending this, where it is, we are asking the selector, so it's complete signature of this. So when we
So
say
it,
receive,
okay.
it's doing it directly. So we can pass, it's a 4 byte of a message signature. It's in 4 byte.
Thank you, sir.
Okay, so once it is done, let's say it is trying to do some call. Okay, so our contract is done, which will receive the request and then callbacks our function of our contract. In this example, the contract and the thing I mentioned about the internal and the external type of function which can be passed will not apply because we are sending the signature. Okay, so now let's move to Okay, so now we wanted to call this test call function. So once it is called, the request will go to this function. It will receive, that function will receive the call. It will do some processing and then it calls back the function. So that's the scenario of callback function. We generally saw this in JavaScript and all those dynamic languages. The callback concept of callback is being used too much. So that's the same thing we can use in our Solidity as well, Solidity contract as well. Okay, this is done.
This dot address, then will it tell us the address of the original function or where the function has been passed?
Which dot address?
If we do, let's say, want to find the address of this dot address or anything to get the address of the current execution point. So will it use the address of the original function or where the function is being sent?
Yeah, so that depends on how you issue this call. We are using the call, so that will be the call of this contract. If we call the delegate call, then it will be the call of a function which is being called, the request which has initiated all these things.
Thank you. Thank you.
Okay, so that's done. Okay, so when this call is done, we'll go to here and we can see request demo receive is started. Request demo is now. Check the sequence. We call this test function. Once we call this test function, request came over here. It calls the receive request function, which is this one. And receive request says request demo started, which we can see over here. Request demo started. Then we call this callback function over here, which send request to here. So call demo value, which we can see over here. And once it is done, we can see the call from this request. So at this moment, it is not asynchronous, but you can make it asynchronous. You can save it for the later. So once you receive this address, you can keep it at the state level, and at the completion of some task, you can call this function. So that's something you can manipulate, or how it depends on the domain of your of your project, how you wanted to use it. At this moment, it is sequential, but we can do it anyway. So what you need to understand is it is a type of a callback function. So you pass your function to the contract, and that contract can later on call your function. So that's the main idea. And around it, you can play around with any way you wanted to use it.
So as you mentioned that the function which we are want to call using the parameter, inside the parameter, it must be either in internal or external. But here we are using all public functions.
That's why that's why before running the code, I mentioned that because we are using this signature work. So at this point, it will not matter that it is internal or external, because we are using with the extension name of the signature. I'll show you the another example in which I'll call the function with the definition of a function. Then you will see the difference.
Okay, got it.
Okay, so that's one thing. And this is what a chain link is built upon. Chain link is doing too much of this. This is the one basic example. Chain link is doing too many things. One of the example is this one. So chain link need to call your function back in all these scenarios, whatever the channeling is doing, they need to call back your function. So they are using this functionality. Second is the events. Channeling needs to update the server, need to call an HTTP request, then receive event, and then fire the event. So all those things. So channeling mainly doing these two things to the whole, to running whole the architecture of a channeling. There are many other things, but basically these are the two ones. Okay, now that's how we call a function, or using the callback function with name of with the signature. We say this dot receive data dot selector. But what if we wanted to call a function like this? We wanted to create a function. Let's say our request demo class, it has another function. Function request. Now we wanted to specify what kind of function or what type of function we wanted to. These are the parameters, right? We pass here u in 256. That means we are accepting u in 256. Here we are accepting a function. So we'll say function which accepts u in 256. It is a pure function or maybe a view function, and it returns u in 256. So this is type of a function. So for that, let me, when we say u in 256 a is a variable and u in 256 is a type. So that's what we are accepting inside the function. So we are accepting this input. In case of function, when we say, so that's the complete signature of a function. So we are accepting a function which takes input 2 in 56, it returns 2 in 56. And what's the name of a variable? In case of u in 56, we name it a. We can say abc. That means that's the variable, that's the name of a function. We can say demo call, maybe, whatever the name we can give it to him. Now you see the error. Internal type is not allowed. Internal type is not allowed, only public or external function. For a public or external function, because this function is public, so you cannot make it internal, you have to make it external. Then it will work, otherwise it won't work. Now we have this function. What we can do is we can just call it, and what we wanted to pass it, it accepts u in 256. So we'll say 23, and what it returns u in 256. So we'll say and let me console it so that
So this demo call is name of the function?
yes, we named it here.
Oh, okay, sir.
As I mentioned previously, that when we create a parameter of a function, first one is type, another one, second one is the name of a variable. So in this case, this is the type. So actually we are defining a function that we are accepting this type of parameter. And what is the name of parameter? It is the name of parameter is demo call. Because this parameter is a function, so we can say demo call 23.
Thank you, sir.
You see, Solidity or the blockchain is not just ERC 721 and ERC 20.
Yes, now we are getting it.
Okay, so we wanted to display this value. Okay, so that's what we have created a function, receive function request with the external name and everything. Now what inside the caller demo, what we can do is we can say test new function call, just name it anything at this moment so we can understand. And inside this we're using the request demo contract, and we are saying that we wanted to call this function. Now this function asks we need to pass function over here as the reference of a function. In this case, what we did is we passed this dot selector dot receive dot selector. Why? Because we were accepting the byte 4, the name of a in what you call the byte 4 converted name of a function. Here, what we can do is receive and then we'll pass this function over here. Okay, now it's saying error because the signature does not match, because what we are accepting a function which is external. We can make it public. It accepts u into 56 and it returns to u into 56. We are not returning anything, so from here we need to return. So let's say whatever we are receiving, underscore value multiply by 2. Just multiply it and return it. Now what it says, it's a view function. You see, now it's working fine. So the view should also work. From external, we can make it public, but we cannot make it internal and everything, because it needs to be, if it's internal, it will not be able to, we will not be able to call from any other function. Okay, now this is the function which will be passed as a reference into this function, and this receive function will receive it over here, and inside this function will say demo call. So we are actually passing a function, and it will call this function, whatever the value it has, it will work like this. Okay, so now in deploy 2, instead of calling the test function, let's call what's the name of the second function? Test new call. Okay. So we have test new call function, which is over here. It will initialize this contract, send function over into this, which will be here. It will call this function. So once it calls this function, the call will again comes back to here. It will use all those things. It will return something, and it will go back to over here. So this way, what you can do is basically at this moment, I'm just calling it immediately. What you can do is you can keep the reference of this contract somewhere. Let me just show this, and then I'll show you. We can keep this at reference of a function somewhere, and then we can use it at the later stage. Okay, so the call is done now. As you can see, receive data value 23 and after 46. So what is happening over here is we call this function. The request went to the this function. It just receive over here. We send this new data function into this receive function request. This is the receive function request. After receiving this call, it just called the demo call 20 and passed the value 23. So that 23 went to the this function again here, and it received over here. So you can see the display receive value 23. Once we receive, it multiplies it. After the multiplication, it sends it back. It received it and it printed the value after the call. So you can see the 46. So you are passing the functions in the same way. You can return a function from a function as well. Now, what you need to understand is we do not have to immediately call this function. We cannot just you always have to call this function. What we can do is what we did, we have actually, just like we do with any data types, we can pass a int variable uint256 and we can store into the state, and at the later stage we can call it. So in this case, what we did is from here, we just pass this function into this demo request function. So we have passed it. What it does is it just getting this function and storing it, saving it for the later use. And at the later stage, whatever the function, whatever the requirement we have at that point, maybe there's another function. And then that function is trying to call it at some later stage. Okay, now it has a name of my call. So that's how you can pass a function. That function will store to the other contract, and then it can be called at the later stage. That's what you can do with this type of functionality.
So,
Any question over here?
it seemed like we have somehow updated the state, yeah, like with the my call. Like
Sorry?
this my call, will it be updated in the state?
I don't get your point.
We are storing this demo call into my call, yeah, the value of the demo call into my call.
Yes. Yes, exactly.
And sir, one more thing I would like to know, that
Yes, the way we generally do, the way we let me just show here or something else. The way we created the variable and when we store it here, that's exactly like this. Yes.
and sir, what if the function which we are taking as a parameter is state changing variable?
We are done with this. I cannot hear you. You might be breaking, or your mic is off.
I think it's lagging. I just want to ask that,
I just heard the last statement. Either it's a problem at my end or your end. I just heard the last word.
Vishant, I think it's from your end. We cannot hear you properly.
Sir, can you hear me now?
Give me a moment. Give me a moment. Can you hear me clearly now?
Yes.
Yes.
Yes, sir.
Okay. So yes, you are asking something. Someone. Any question? Okay. So can anyone confirm if you can hear me clearly, or it's still the problem with the internet?
Yes, we can
Yes,
hear
sir,
you.
we can hear you.
Okay. 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 So mainly we have seen the delegate call, and static call, and how we can call the external function using the we can pass the parameter function as a parameter, and how we can use it. This Oracleized service, it's exactly what I was explaining, but with the different example. And the last thing will remain, I think we can save it from the next class, is the yes. So two things remain, so we can move, we can leave that for the next class. We have to
Sir, there are two voices coming. I think I'm not sure it's only me or it's anyone else as well.
is there a problem with anyone else as well?
From your side,
No,
Abdul Wahid, I think.
voice is clear.
Yeah, because I think it's a playback or whatever, but we are hearing two voices. Now I think it's fine.
Okay. Okay. So anyway, we are winding up. So
So just last question.
Yes.
In the last example, we took function as a parameter. Yeah. What if we take a function which is state changing function as a parameter? Can we take it? Which changes the state. Like at the moment, we only took view function.
Yeah, basically, just a moment. Okay. So if we wanted to make it like this, right? So we are basically passing what it's trying to say. We can change, remove the view, and then we'll be able to access the function. So it will be the function is the state changing, so it will work as a state changing function. So it can change the state. It will change the state. So, and it will change the state of a function of a contract in which it is being called.
Got it, sir. Thank you so much.
Okay. So let's wind up over here, and there is one example which we'll cover in the next class, and then we'll move forward.
Sir, one last question. Actually, I'm sorry, I joined the class late. Can you tell me the reference of this book? The book we are following.
It's the let me show the name of the book. It's available on PackPub. It's Mastering Blockchain Programming with Solidity. So it's available on PackPub website.
Okay, sir. And which chapter we were following?
Second, chapter 2. We were discussing the chapter 2.
Okay, sir. Thank you very much.
No problem. Okay, then I guess we're just a moment. Okay, bye everyone. We'll see you in next class.
Bye, sir.
Thank you.
Allah Hafiz.
Thank you.
Thank you, sir. You are putting so much efforts. Thanks a lot. And Allah
Thank you.
Hafiz, sir.